Alright guys, hopefully you have your note sheets ready, and we're going to give a lesson tutorial on ratios, rates, and proportions today. Let's start out with some vocabulary. We'll define the three words ratio, rate, and proportion, and you should be able to tell us the difference. And in fact, once I'm done with this vocabulary, you should pause the video a minute and answer the first question on your worksheet as to what the difference is between a ratio and a rate. So try to pay attention to this. A ratio is defined as a comparison of two different quantities with similar units. Now that can be a little confusing sometimes, and hopefully some of the examples that we talk about will bring that out. And sometimes we will even write it as a fraction without a label if the units are similar enough. So let's go to the next slide and see some examples of what might be a ratio. Okay, let's look at this picture. Now one thing I want you to notice is that if we look at this picture, it is similar items. Specifically, we're looking at fruit here. But when we compare with a ratio, we have to compare different quantities. So let's compare the quantities of bananas to the quantity of tangerines. So if you look at the bowl and count the bananas, you get 1, 2, 3, 4 bananas. So we would say, okay, 4 bananas to 1, 2, 3 tangerines. So we would say that is 4 bananas to 3 tangerines. That's a long way to write it, so what we might do instead is we would just say, well, the ratio of bananas to tangerines is 4 to 3. And oftentimes we replace the word to with a colon when we talk with ratios. And sometimes we may even write this as a fraction. So we would say 4 to 3. And so those are the different ways we can represent ratios. You'll see, again, the top one is longer and includes the units. We kind of take away the units as we speak about it, though. We say it's a ratio of 4 to 3 with bananas to tangerines. Now here's another picture, and we can talk about ratios here. One thing I want you to notice is that these are all people. But we can be more specific. Maybe we want to know something like, what is the ratio of boys to girls in this picture? So why don't you look at the picture a minute and try to figure out the ratio. I'll pause speaking. Hopefully you were able to do that fairly quickly. And if you look at the picture, one thing you see is we have to look at the number of boys. So we have 1, 2, 3 boys. And then we have to look at the number of girls. And we have 1, 2, 3 girls. And so our ratio of boys to girls, we would say 3 boys to 3 girls. Now, much like fractions, we can reduce this into lowest terms, so to speak. And so if we have a ratio of something that's 3 to 3, it is the same thing as 1 to 1. So our actual ratio in this case is 1 to 1 with regards to boys and girls. So that's what ratios are. Just realize the important thing here is we are comparing two quantities of similar things. In this case, with this example, it was people. With the previous example, it was fruit. But then we got a little bit more specific when we were talking about the ratios. We were talking about bananas to tangerines and boys to girls. But they were similar things. Now let's talk about the definition of rate. You can read the definition with me. It's a comparison of two quantities with different units, often using the word per or for each to make a comparison. Now what you'll notice here is instead of with ratios where we talk about similar units, here we are definitely talking about different units. So let's look at an example or two for rates on the next slide. So one of the most common examples for rates I can think of is when we compare distance to time. And so if we have distance compared to time and write it as a ratio, we get things like miles per hour. And we might write that as a fraction, miles per hour. But make sure you notice that these are two very different units. Miles is distance and hours is time. We would not consider these similar units at all. Another common rate you might come across in something like the grocery store, where you compare the cost of something to the amount, let's say pounds. And again, notice these two are very different. Cost is money, pounds is weight, yet we can compare the two by making it a rate. Maybe it's a dollars amount per pound. And so that is a rate, but again, we very different units that we're comparing there, and we make into a rate. One other concept I want to talk about really quickly here is something called a proportion. This is a statement that two ratios, and I'm going to add here, or rates are equal to each other. So we will talk a bit more about proportions and how we're going to use them later, but let me give you one example. So one example of a proportion would be, let's say I can hike, I'm going on a hike, and I can hike 7 miles in 2 hours. This would be a rate. You can see here we have miles and hours, two very different units. And then a proportion to that, proportionally, we would say that if I hiked for 8 hours, I would travel 28 miles. And so because I write it like this here as two fractions with the same units on top, you can see here miles, and then the same units on the bottom, we can see hours and hours. And so this would be considered a proportion when it's written like that. We have two rates, and they're equal to each other. We are actually going to use this concept later to solve a lot of different types of problems. So this concept will come out more later in our learning. All right, now what we're going to do is we're going to move on, and we are going to learn how to calculate rates. And to do this, what we do is we do division. Just a quick reminder, rate is two quantities with different units. And that's the concept we're going to be using. And simply what you do with those two quantities, for example, in this definition here, what you will see is we have quantity A and quantity B. We divide them. And so if we have two quantities A and B, what we would just do is do A divided by B. And that would give us kind of this statement down here. We would have A per 1B. And we'll kind of see how this works with some examples. You are expected to follow along in your notes for the next few examples, so please show your work along with me. So let's look at our first example of a rate. We have the problem here. It says if Tom can run a 12-mile course in 2.5 hours, how fast was he running? And I guess you have to kind of realize we're talking about a speed here, and we usually do a distance over time for that. And so the rate for this would be 12 miles over 2.5 hours, and I'm just writing that as a decimal. And now I just do division. And I take 12 divided by 2.5 and I get 4.8. Now my units for this is we take the units from the original problem and write them as a fraction, and I write it as miles per hour. And I think that is the way we need to look at it. So the answer is 4.8 miles per hour. So here's problem number 2 for rates, and it says we have a package of chicken weighing 4 3/4 pounds, and it costs $5.70. What is the price per pound? An important part of this problem is right here. This kind of tells us how to set it up. What is the price per pound? The price goes on top, the pounds go underneath. So we put the $5.70 in the numerator of this fraction, and we put the pounds on the bottom. Again, notice I'm changing the fraction to a decimal, and if you can't do that in your head, you take your calculator and do 3 divided by 4 for the fraction. So the pounds go on bottom, and if we calculate that out, we would get 1.2 dollars per pound. Now it's a little bit strange to write it like that. Hopefully you recognize what we're talking about, money here. So we would probably say this is $1.20 per pound. And that would probably be the more proper way to write it, though the way I originally wrote it isn't wrong. It's just kind of a little strange compared to what we would usually see. So on to example number 3. It says Maria has to read Pride and Prejudice in 2 weeks before school starts. If the book is 268 pages long, how many pages should she read each day? So again, we have the situation, we want to know how many pages per day, and that just more or less tells us how to set up the problem. We want pages on top of the rate, day on the bottom. So we would take 268 pages and we want to divide it by the number of days. Now, part of the problem in this problem is we're not given the number of days, but if you look closely, we see the quantity 2 weeks. And again, hopefully you can use your brains a little bit and try to figure out how many days that is. And you should say, well, that's 14 days. And so this is our rate. When we divide it, we get that she needs to read 19.143 pages per day. Now, the reality of it is you can't read 19.13 pages per day, so this is a problem where you should probably round and say Maria should read 20 pages per day. Notice I rounded up, not down, even though down was closer, because if she read 19 pages per day, that would not get her to the 268. She would be short of that. So the correct answer for this one is 20 pages per day. And again, that is a rate, and you can see our unit is written as a fraction. Okay, here is the last problem. I would actually like you to try to figure this one out on your own. So please, why don't you pause the video? So hopefully you paused it and you figured this out for yourself. So let's go through it now. You want to figure out the cost per ounce, so that would be dollars per ounce. And again, this tells you how to set up our rate. We should take the $2.70 and divide that by 8.2. and that will give us 0.3293 dollars per ounce for this one. And money wise, this doesn't make sense, so we would probably say it's $0.33 per ounce, which hopefully you understand by looking at that number that is 33 cents. $0.33 is 33 cents per ounce. Looking at our next one, we would set it up in the same way, except we would take the numbers given in this problem. We would do $2.25 and divide that by the 6.4 ounces. And when we put that in our calculator and calculate it out, we get $0.352 per ounce. Again, doesn't make much sense with money, so we would go to the hundredths place, $0.35 per ounce, and that would be 35 cents per ounce. So which one is the better buy? Hopefully you can see that the first problem you did is the better buy. At 33 cents per ounce is cheaper than 35 cents per ounce. Alright guys, that wraps it up. So hopefully you took your notes and you did your problems and you have a better understanding of rates and ratios and proportions. Again, we'll get more on proportions later, but hopefully you can calculate rates now, because we're going to be doing a bit of that over the next couple days in class. Have a great night, guys.